This is Mr. Anderson for Math 121 with our part 2 of our complex numbers and using the number I for the imaginary number. This is part 2 from the first part of the video. I do have to review a couple of things before we get started here. The first thing to remember is that the square root of -1 is the letter I, and if I have I squared, that's going to be equal to -1 because I squared is the square root of -1, and the square root of -1 times the square root of -1 is going to be equal to -1. So just a couple things to remind us about that. I is equal to the square root of -1, I squared is -1, and also another analogy is we have to have our answers in a+bi format, where if we have any non-imaginary numbers, just whole numbers or radicals or anything, that has to go in front, plus b, any number that's multiplied by our I. Even so, most of the time b is going to be 1, but sometimes you find it a little different. In problem 11, we're going to do some FOIL. So this is going to be 8, and this is going to be plus 12i plus 2i, and then we have plus 3. I times I is I squared. So this is 8 plus 14i, and this 3 times I squared is the same thing as saying 3 times -1, because I squared is -1. So therefore this is -3. So we'll have 8 minus 3, which is 5, plus 14t. Here's your answer for number 11. We'll do our FOIL here. This is -12. This here is -16i. This is positive 15i. And then this is -20i squared, because I times I is I squared. So we've got -12. -16 plus 15 is -1i, or just -i. And this -20 times -1 is going to be positive 20. So this gives us -12 and 20, which gives us 8 minus I. All right, moving on to this. This is important because we're going to be using this for problems 15, 16, and 18. This is going to be a situation where you have the difference of squares, or the difference of these two terms here. Notice this binomial is exactly the same. The only thing that's different is that in this situation you have a plus and a minus between the two binomials. So -4 makes positive 16. That's our first cable. -4 and -5 makes -20i. And then check this inside cable. This is going to make a positive 20i, which is pretty handy for us. And then we multiply by these last two cables. This is negative 5 times 5 is 25i squared. Okay, so these two simplify because they're opposites. So I've got 16. Now the minus 25i squared is like plus 25, because -25 times -1 is positive. So that's going to make a total of 41. Now, the reason why 13 gets a star by it is because we need that for 15, 16, and 18, because we cannot have this in the denominator. Cannot have an I in the denominator, which is the square root of -1. And since I is a square root of -1, this violates the third rule of simplification, which says that we cannot have radicals in the denominator. Now we're going to write this twice. So we're going to have 3 plus 2i and 3 plus 2i. The binomial squared means any binomial squared means write it twice. Our first cable is going to be 9. Second cable is going to be 3 times 2i, which is 6i. And our third cable is going to be the same thing, 6i. And our last cable is going to be plus 4i squared. So 9, and this, I'm going to kind of speed up a little bit here, because 6i and 6i make a total of 12i. 4 times I squared is like 4 times -1, so this becomes here a -4, and that means 9 minus 4 is 5. So 5 plus 12i is our answer right there. Okay, so moving on to problem 15. We need to get this 5 plus I out of the denominator, and to do that we will use the trick that we used 2 sections ago, where we're going to go 5 plus I, 5 plus I, multiplying top and bottom by the same thing. This means our numerator here is going to be 26 times 5, which is 130, plus 26i. Now our denominator is going to get FOILed, but look what happens when we FOIL. 5 times 5 is 25. Then I get 5 times I, which is 5i. Oh shoot, I should have used subtraction here. So let's rewind a little bit. This should be a minus, this should be a minus, and then this should be a minus. So sorry about that. Alright, so let's rewind here. So 26 times 5 is 130. 26 times the negative I is negative 26i, or plus negative. Here, I'm going to take 5 times 5, which is 25. 5 times negative I is negative 5i. And that means when I get 5 times I, this is going to be positive 5i. So these two middle i's simplify to 0. Now negative and positive make negative I squared. So these two terms simplify. Negative I squared is a negative 1. So negative 1, since our I squared is negative 1, this makes a positive positive. So 25 plus 1 is going to be a total of 26. Now what's kind of neat about that is that our numerator, since it's a multiple of 26, we can basically simplify this fraction to be 130 over 26 minus 26i over 26. This is acceptable because this is a monomial in the denominator, and this simplifies back down to 5 minus I. And there's our answer. Now the reason why I did that kind of simplification is because we're going to be using the quadratic formula coming up in the next chapter. So it's best when you have a binomial divided by a monomial, you split it up and solve it this way. Alright, let's go to number 16, and I'll try to be very careful to make sure I put 4 plus, so I just did it again, shoot, 4 minus 2i, and I'm going to go 4 minus 2i here. So it's the opposite binomial. So it looks like in my numerator here, I'm just going to multiply, the first is going to be multiplied by 12i, because 3i times 4 is 12i, and 3i times our negative 2i is going to be a negative. Boy, I'm saying the wrong things here. 3 times negative 2 is going to be a negative 6i squared. All right, now that's my numerator. Now let's go FOIL our denominator. 4 times 4 is 16. 4 times negative 2i is negative 8i. 2 times 4 is 8i. And then we have 2i and 2i. Well, that's going to be a positive. No, it's going to be negative because negative 2 and positive 2 is going to be a negative 2i squared. Alright, just to go over that again, 4 times 4 is 16. 4 times negative 2i is negative 8i. 2i times 4 is 8i. And then 2i and negative 2i makes a negative, 4i squared. Wow, I'm sorry I'm making these little mistakes in the problem. Good thing I went over that a second time. So, because when we have 2 times 2, that makes 4. And then the I times I makes I squared. Whew, alright, sorry about those little mishaps there. Let's do some simplification. In my numerator, I'm going to have 12i, and here's an interesting thing. I got negative 6i squared. The I squared is negative 1. So this is really negative 6 and the negative 1, which makes a positive 6. So we'll put that in front. Then we have our 12i, so I'm going to put my plus 12i right there. Now let's take a look at my denominator. Well, these guys simplify out, which is pretty nice. And I have this negative 4 times the I squared. So negative 4 times the I squared, this is going to be a negative 4 times negative 1, because I squared is negative 1. So this makes 16 plus 4, which gives me a total of 20. So this whole thing is over 20. And that could be the end of your answer, but since we're moving towards quadratic formula, I want to push you just a little bit further. Because what I need you to do here is I need you to take a look that 6 over 20 and 21 over 20, they're both odd, or both even. So what we can do is we can split this up and simplify it. So 6/20 plus 12i over 20ths. And what this will do is this will simplify the 6/20 will simplify by 2 to be 3 over 10. And this will simplify by 4. See, 12 and 20 can both be divided by 4 to make 3i over 5. And that is the super simplified answer that will get you a little bit closer to doing things in getting closer to do things a little bit in our quadratic formula unit. All right, got a little bit more to go here. Let's go take a look at 17, 18, and this bottom part here. Okay. Now, for problem number 17, we don't really have to do that much to get rid of our denominator of 5i. So I'm just going to multiply this by, in our numerator here, 5i over 5i. And this means the top gets distributed by 5i. So this is, since that's a monomial there, instead of FOIL, this is going to be 10i plus 35, I times I is I squared, all over 5i and 5i, which makes 25i squared. Now if I look at my numerator here, this is 35 times I squared, and I squared is negative 1. So that means I'm going to have 10i, and then my 35 times negative 1 is negative 35. Let's move that out front, negative 35, because I want to have my whole numbers, then my bi, or I with the number in front of it. This here is going to be 25i squared, so what this does is it means that it's a negative 25. Now again, because we're moving closer to the quadratic formula chapter, it's probably best to do a little bit of work here to do some simplification. So let's work on that. So what I'm going to do here is I'm going to remove, let's say I got 35 over negative 25, and then I have my 10i over negative 25. And if I simplify that fraction, 35 divided by 25, both can be divided by 5, so that leaves me with 7 over 5. Notice it's positive because two negatives make a positive. Now here this is going to be a minus because you have a positive divided by negative, and this is going to be 2i over 5. And this gets us really close to our getting better with the quadratic formula chapter next. Alright, so our last problem here for this video, I'm going to make a third video for problem 19 through 27. The third part here is we're going to multiply by 7 plus 4i. 7 plus 4i. And we're going to do our distribution here. 3 times 7 times, let's see, do our FOIL here. This is 35. And our next cable is going to be 20i. Our next cable is going to be 21i. And our last cable is going to be 12i squared. That's just our numerator. Woo. Now we look at our denominator, which is going to be 49 plus 28i minus 28i, and then finally minus 16i squared. Those two simplify out. Let's look at our numerator here. That changes, this 12 here changes to a negative 12. So 35 minus 12 is going to be 23. And then the 20 and the 21 make a total of 41i, all over. In this case, my negative 16i squared turns into positive 16. So I add that to this, which is 65. All right, well, thanks for watching, and we'll have a third video covering 19 through 27.